Hi, this is going to be a walkthrough on how to set up and demonstrate the operation of the Hirschman data diode. So the Hirschman data diode is effectively two layer 3 routers back to back, and represented here we have one of them. Here's the other. I've given both of them an IP address 192.168.1.1 and 1.2 respectively because you need to manage them individually. So within this router, I have taken this port here. This is port 1. I've given it a routed interface of 10.100, and I've given this one here a routed interface of 1.1. This is the simplex connection, so it's a transmit only. There's no receive coming back in of this layer 3 router. This happens to be port 8, and this is port 8 over here as well. So this is a simplex connection. It has 1.1. It's connected to 1.2. And on this one here, I've given this a 20.100 IP address. So different subnets. And what I then have done is I've also gone in here. I've set up a static ARP within this unit so that it actually is aware as to where port 1.2 is, which is this IP address, or sorry, this MAC address. This MAC address just happens to be the MAC address of this interface right here. I've also given it a static route so that it's aware as to where that there is a 1.2 out there. And then in order for me to demonstrate all of this, what I then have is I then have a data source. This is where my, in this case, UDP traffic on port 514 is going to come from. 514 is syslog traffic. And I'm going to essentially just take Ostinato, which is a packet generation software application, and I'm going to generate UDP on port 514, inject it into this port with a destination IP of this, which is effectively just where I'm running Wireshark on. In order to demonstrate all of this utilizing my laptop, which is connected to a docking station. So my docking station has a 10.10.10.99 address, and my laptop itself has a 10.10.20.99 IP address. And I know for a fact that the data generation can be pointed at a specific LAN interface, as can Wireshark, and thus there is no internal traffic taking place. And in order to set up the packet capture for UDP on 514, this is how I have Ostinato set up. So my packet generation is going to take place from my laptop. So this is my laptop port. My laptop port has a 10.99 address. That is this port right here. And what I've done is I have configured this such that, let me grab this and drag it down, such that the stream is Ethernet based. It's IPv4. It is UDP, and the destination address is this. This destination address is this port right here. That is the MAC address of this routed interface, and I then am putting in a source IP address of 10.99 because this is where it's coming from. This is where it is headed, which is this address right here for where my Wireshark is running on. And I'm forcing it to be port 514, so it's going to be interpreted or viewed as syslog data. And just so that I can find it relatively easy, we will use, for example, all nines. And aside from that, we're looking at 5 packets per second. Number of packets being sent are 2. And once this is done, it's then simply going to loop back over and repeat itself until this is then stopped. So hence the go to first option. So with this, I then apply it, and I then start the transmission. You can see the frames sent is incrementally rising, 24, 30. So I know that it's sending, and just to confirm that it is also being received, what I'm going to do is I'm going to take the patch cables and I'm going to jumper them together using a coupler. So effectively I'm taking this port here and jumpering it directly in with this port here, so that I'm effectively bypassing the data diode. And what I'm going to do is I'm going to run Wireshark, and I want to select my docking station. And you can see here I have a filter. The filter is looking specifically for traffic on port 514, UDP traffic. And you can see all of my syslogs here. And if you look at the data content, which is why you see all the 9s here, I know for a fact that this is actually the syslog that's coming from 10.10.10.99 to this. And if I now sever this, so I've disconnected the 2 patch cables from the coupler, I know for a fact that this has now stopped. So with this, I will now show you the actual configuration of the routers. So I'm currently plugged into 10.10.10.100, and for routing global I have it enabled, and the configuration is such that the Pi server, this is where I have the customer's incoming UDP traffic on port 514, is connected to port 1. It has a routed interface of 10.10.10.100. Routing is enabled, and this is the outbound traffic. This is where I have the simplex connection going to the other interface. I've given it a 1.1.1.1 24-bit subnet. Routing is also enabled for that, and so that this port is aware of the other device, because it cannot receive any ARP responses. What I've done is I've actually set up a static ARP. This is the IP address of this port here, and that port there is this port, and it has this MAC address. I was able to find this MAC address because when I configured this switch under routing and ARP, you'll see that it has an ARP or MAC address for 1.1.1.2 of this. I was then able to simply copy this and then paste that into here, obviously making it active. I then also gave it a static route, this just so that anything in any subnet, the next hop is automatically going to become the 1.1.1.2. So this done, I then went to finish configuring this. This is the data outside, and for this too, routing is enabled. For the configuration, I have my outgoing port, which is the 10.10.2100. This is the incoming data on the simplex connection of 1.1.1.2. Routing also enabled, and that's pretty much it. At that point, you'll see that there's local and dynamic ARPs that already exist, and with this, it's then simply a matter of making sure that the packet generation is taking place, and you can then see that these syslogs are being generated. So we're currently pushing syslog traffic through the data diode. This is a unidirectional traffic, and again, it just shows the fact that we can push UDP traffic 514 in this case through the data diode. I hope that this has been informational and that you are able to replicate this. If you have any questions, feel free to reach out and let us know how we can help. Thanks for watching. Have a great day.